Can you tell me substance used in preserving biological specimens or fragrant perfumes and nail polish removers have in common? Well, all of these are organic compounds containing a carbonyl group, where a carbon atom is double bonded with an oxygen atom. Note the diagram on the screen, the letter A and B represents the other group attached to the carbonyl carbon. The two specific groups containing a carbonyl carbon are aldehyde and ketones. But have you ever thought how we can differentiate between them? Aldehyde differs from ketone in their oxidation reactions. Well, mild oxidizing agents such as Tollens reagent and Fehling solutions are used to distinguish aldehydes from ketones. Now, what is Tollens reagent or Fehling solution? Well, Tollens reagent is a freshly prepared ammoniacal silver nitrate solution. When an aldehyde is warmed with a Tollens reagent, a bright silver mirror is produced due to the formation of silver metal. The aldehyde are oxidized to corresponding carboxylate anion. The reaction occurs in alkaline medium. In case of ketone, they do not react with Tollens reagent. Whereas Fehling solution comprises of two solutions, Fehling solution A and Fehling solution B. Fehling solution A is aqueous copper sulfate and Fehling solution B is alkaline sodium potassium tartarate, also known as Rockel's salt. On heating an aldehyde with Fehling's reagent, a reddish-brown precipitate is obtained. Aldehydes are oxidized to corresponding carboxylate anion. Ketones and aromatic aldehydes do not respond to this test. Aldehyde also easily oxidizes to carboxylic acid on treatment with common oxidizing agent like nitric acid, potassium permanganate, potassium dichromate, etc. Whereas ketone do not undergo oxidation easily because these require breaking of strong carbon-carbon bonds. However, ketones are generally oxidized by strong oxidizing agent like acidified dichromate or permanganate. Their oxidation involves carbon-carbon bond cleavage to afford a mixture of carboxylic acid having lesser number of carbon atoms than the parent ketone. Here, the first two compounds are formed by the cleavage of carbon 1 and carbon 2, and the other two compounds are formed by cleavage of carbon 2 and 3. Also, aldehydes and ketones having at least one methyl group linked to the carbonyl carbon are oxidized by sodium hypohalite to sodium salts of corresponding carboxylic acid having one carbon atom less than that of the carbonyl compound. Here, the oxidation does not affect a carbon-carbon double bond and methyl group is converted to haloform. Do you know both aldehyde and ketones give a variety of compounds such as alcohol and hydrocarbons as a result of reduction? For example, catalytic hydrogenation using platinum, palladium or nickel, or reduction using hydride reagent such as lithium aluminum hydride or sodium borohydride could be employed for the conversion of aldehydes or ketones to alcohol. Here, aldehyde forms primary alcohol and ketone forms secondary alcohol. Whereas in Clemenson's reduction and Wolff-Kissner's reduction, the carbonyl carbon of aldehyde and ketone is reduced to CH2 group. In Clemenson's reduction, carbonyl is reduced to CH2 group on treatment with zinc amalgam and concentrated hydrochloric acid. And in Wolff-Kissner's reduction, it is reduced with hydrazine, followed by heating with sodium or potassium hydroxide in high boiling solvent such as ethylene glycol. The aldehydes and ketones also undergo a number of reactions due to the acidic nature of alpha hydrogen. The acidity of alpha hydrogen atom of carbonyl compound is due to strong electron withdrawing effect of the carbonyl group and the resonance stabilization of the conjugate base. Therefore, aldehydes and ketones having at least one alpha hydrogen undergoes aldol condensation reaction, in presence of dilute alkali as catalyst to form beta-hydroxyaldehyde, that is aldol, or beta-hydroxy ketone, that is ketol. The aldol and ketol readily lose water to give alpha-beta unsaturated carbonyl compounds, which are aldol condensation products. Whereas when aldol condensation is carried out between two different aldehydes or ketones, it is called as crossed aldol condensation. If both of them contain alpha hydrogen atom, it gives a mixture of 4 products. This is illustrated here by aldol reaction of a mixture of ethanol and propanol. Here, the first 2 products are formed as self-aldol product and the other 2 products are formed as crossed aldol product. Aldehyde and ketone also undergo one of the most important reaction, that is Cannizzaro reaction. In this, aldehydes that do not have alpha hydrogen atom, such as formaldehyde and benzaldehyde, undergoes self-oxidation and reduction reaction on heating with concentrated alkali. Here, one molecule of aldehyde is reduced to alcohol while the other is oxidized to carboxylic acid salt. Aromatic aldehydes and ketones also undergo electrophilic substitution at the ring, in which the carbonyl group acts as a deactivating and meta-directing group. We have come to an end of this topic. Now, can you write the chemical reaction that affects the given transformation? Well, recall the chemical properties of aldehydes and ketones. Let's now summarize what we have discussed in today's class.
Manorama Horizon. Learning made simple.